Now that I've introduced the concepts, let me walk you through how this actually works in practice. This data, let me flip over to my PowerPoint. This data comes from Professor Hall's slides. So I took this directly from the slides and copied it into an Excel file so that we could all look at it and take a gander at how this works. So we have 3 companies, and again, this is from our, if we worked in an investment bank, the investment bank would we would have an analyst on each of these, and we would have some states of the world where, like, in some instances there's a low return, in some there's a high, and some there's just kind of the normal course of business, and each of those has a different probability. So usually the way this works is we kind of go through this process, and the first one is just in general, what's the expected return of the asset? And then once we have that, kind of what's the variance and the standard deviation associated with each asset? Once we do that, we talk about the covariance and the correlation between the assets. Notice there are 3 assets. I have 3 correlation and covariance columns. And then we calculate a variance-covariance matrix, we calculate some weights, we calculate a portfolio return, and finally we calculate the expected return on the portfolio and the standard deviation. If you follow Professor Hall's slides, I think I may have closed them, he goes through these step by step, but in a different format. And you can absolutely do that. You can also follow mine. You'll notice that we got to the same exact result. Let me show you a preview of the result. He creates a sample portfolio with a weight on CVS of 60% and a weight on Microsoft of 40%. And when he does that, he gets an expected portfolio return of 12.48 and a standard deviation of 16.08. If you look at this picture right here, the standard deviation is 16.08 and the portfolio return is 12.48. And then if you do it a bunch of times with a bunch of different weights for each stock, you end up with all these little blue dots. And so the spreadsheet that I'm showing you, you could use in 50 different ways to calculate, well, in this case, 18 different ways to calculate the different portfolio weights. But in theory, you could calculate any number, infinite numbers of different portfolio weights based on that. Okay, so let me go here. I'm going to walk you through how to do this from start to finish. And I'm going to do this on a different page. Oops, let me start a new one over here. I was playing around with it. Okay, so this is what we started with. On this video, let's do the expected return, and then the deviation from mean, and we'll start there. Okay, so the first thing is sum product. This is one of the handiest formulas that one can have. And what sum product does is it multiplies 0.3 times 0.5, 0.5 times 0.09, 0.2 times 0.33, and then it adds them all up. And you get 12.6%. Let me lock this. So if you notice, I'm locking the probability cell so I can just drag it across. You end up with 12.6%, 12.3%, and 11.1%, and let's just check. That is exactly what we have here. The intuition on this is that the expected return is a function of the probability times the different state of the world. So, you know, some states we're going to weight higher because they're more likely to occur, like the normal state, and some states we're going to weight lower, like the high state, because they're less likely to occur. And again, this is like a way that banks or consulting firms or whomever kind of backs into what the expected return could be. And that's because some states are more likely than others. All right, deviation from the mean, very, very simple. I'm going to lock the row, but not the column. All right. right, now we're going to square it. Okay, now we need the variance and the standard deviation. Okay, so we have, these are kind of the squared variances, and remember we can't just add up the deviation from the mean. It's not quite correct. So we have the squared variances. If we do another sum product, probability and the variance, and I'm going to lock these. So what we have here is the terms that are, so for instance, on CBS, the variance for the low state of the world is 0.005776, and there's a 30% chance of that happening. And so we need to weight the variance for each of the individual observations by the probability of it happening. And then the standard deviation is that to the power of 0.5. Let's change that to a percent format, add a couple decimal places, and lo and behold, we have the same answers here. So the intuition on this is that we have variance, we have different returns, we have different probabilities of those returns happening. We need to calculate the variance for each of these returns in the different probabilities of those states of the world occurring. And once we weight the variance with the probability, we end up with the variance, which is this number. And once we take the square root, we end up with the standard deviation, which is the 10.35% in the case of CBS.